Hello, my name is Jacob Buell. This is Lab 4 about magnetic braking with Faraday for Physics 2212. So for an introduction to this lab experiment, the aim is to show the results of Faraday's law by conducting real-life experiments and developing computational data. So certain principles such as Faraday's law, Biot-Savart law, Ohm's law, and magnetic flux are important to know. So Faraday's law, it can be written as surface integral of E dot dl, which is just the nth, is equal to the negative rate of change of the integral of the B field dotted with n hat times dA. The Biot-Savart law can be written as B is equal to the mu naught over 4 pi times QV cross R of R hat. Now magnetic flux, that is the integral in the Faraday's law equation. It is equal to the integral of the B hat dotted with n hat dA. Now Ohm's law, it can be written as delta V is equal to the current times the resistivity. So in this lab, I conducted an experiment using aluminum foil and a magnet to see the results of Faraday's law. And then I also created a glow script model to create the same experiment computationally to try to determine the same results. So for the real-life experiment, the system was the magnet and the surroundings were the foil and everything else. For the procedure, I used my phone magnetometer to determine the north end of the magnet being used in the experiment, and then recorded the time the magnet takes to fall inside the aluminum pipe, and then repeated that around 5 times. So important values to know for the glow script model in the future are the pipe width, length, the mass of the magnet, and then the magnetic dipole. So these values are written here. And then for the experiment results, for each trial 1 through 5, have the time in seconds, and the average of these trials came out to be 1.222 seconds. So for a checkpoint question, why can a ferrous pipe not be used? The answer is the ferrous pipe would become a magnet itself, causing unwanted interactions with the magnet falling in the pipe. Now what happens to the magnet? When the magnet falls, flux is created, which in turn creates an induced current that creates a magnetic field. And this magnetic field creates a magnetic force that points in the opposite direction of the force of gravity. And when these two cancel out, F net is equal to 0, which causes the magnet to fall at terminal velocity. Now for the glow script model of the experiment, here we have the values in the bottom put into the glow script model, and you can see in the top left, and you simulated the magnet falling through the aluminum pipe. Now here's the graph of the velocity over time. You see there's a slope, which means F net did not equal 0 the entire time, as the acceleration was changing, or speed was changing. And the time in the tube came out to be 0.25 seconds, which is significantly different. So some reasons for this possible error from the glow script model to the real-life experiment could be human error when measuring the time. I could have errors calculating the magnetic dipole from the previous lab, and also under the assumption that air resistance is negligible, could be an error. Now interpreting the results, the color red is the counterclockwise current, while blue is the clockwise current, because the magnet was increasing during the red, and this was determined using the right-hand rule. If I were to flip the magnet around, everything would stay the same except the magnetic field and the current would flip, and the magnet would still be repelled upward. So in the real world, it's more likely accurate because of that difference in data. And again, a flat slope would mean there's 0 net force, while a slope means there is a slight net force acting in a direction. Now, what if the resistivity of the conductor was reduced as close as possible to 0, then the current would increase until it is equal to the gravitational force. So the magnet would fall slower, but if holes and slots were cut into the tube, then the holes would disrupt the induced current and therefore increase the speed that the magnet would fall through the tube.